In this video, I'd like to talk about the math question of the day for Thursday, July 13th, 2023. And with this problem, we need to find the zeros of this polynomial, p of x. And finding the zeros of some polynomial is something typically taught in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And when we say to find the zeros of a polynomial, we could also say we need to find the roots of the polynomial. We're wondering which x values would make this polynomial equal to 0. And since the polynomial is already factored, it's written in its factored form. These are all just linear factors where x in each of these is to the first power, then it's fairly straightforward and we can use what's known as the zero product property. Essentially, if we have, let's say, two factors, a times by b, and we know that they must equal 0, then either a could equal 0 or b could equal 0, since 0 multiplied by anything is 0. So with these factors here, if any of these factors are equal to 0, then the entire polynomial would be equal to 0. And essentially, we just need to figure out when or which x values make each of these factors equal to 0. And let's start with this one right here, x plus 1. If we plug in an x value of -1, then we get -1 plus 1, which is 0. And it doesn't actually matter what the rest of them are, since we'd have 0 multiplied by some numbers, which would be equal to 0. In fact, if you do want to plug it in, we'd have -4 multiplied by -4 multiplied by 0 multiplied by -7. But again, all of that multiplied together is just 0. So one solution here for this polynomial, for the zeros of this polynomial, we have x is -1. And for the simpler linear terms, it's relatively straightforward to figure it out. For instance, with this factor here, we can see that if we plug in an x value of 3, we'd have 3 minus 3, which is 0. And again, 0 times anything is 0. So another solution is 3. If we look at this factor here, if we plug in 0, we have 4 times 0, which is 0. And 0 multiplied by -3, multiplied by 1, multiplied by -5 is, of course, 0. So that is another solution. Now, when we have a slightly more complicated linear factor, then we do need to be a bit more careful. But what we can do is just set that factor equal to 0. We can say that 2x minus 5 must be 0, and then solve this two-step equation. We can add 5 to each side of the equation. We can divide everything by 2 to cancel out that multiplication. And we get an x value of 5/2. And of course, if we test this, if we plug in 5 over 2 here, 2 multiplied by this, the 2's cancel, and we get 5 minus 5, which is 0. So our final solution then is 5 over 2. And we should expect 4 solutions here because we have 4 linear terms multiplied together. In fact, if you multiply all of this out, which is a bit tedious, what you will find is that the leading term here for this polynomial, if we multiply all the highest power terms in each of these, 4x times x times x times 2x, we would get 8x to the 4th, and then have a bunch of lower power terms. But since the degree of this polynomial is 4, we know that we have at most 4 zeros for this polynomial. In fact, that's the exact amount that we have, though they might not all be real zeros in some cases. In some cases, we might end up with complex zeros. But when we include both the real zeros and the complex zeros, since the highest power is 4, that's exactly how many we would have. So these x values right here answer this question. These are the zeros of the polynomial p of x.